Welcome back. Today we will be talking about complement and addition rules in probability. If you have not watched the previous videos, I highly recommend watching them. So this video becomes a breeze. So let's go ahead and start with the addition rule first. Remember in probability, when you say the word or, that means you're adding the two probabilities. Let's go ahead and take a look at the formula probability of A or B when A and B are two events of a sample space. It's probability of A plus probability of B minus probability of A and B. So let's go ahead and do the first problem. If A and B are events, probability of A is 0.1, probability of B is 0.3, probability of A and B is 0.6. They're asking us to find probability of A or B. Plugging into the formula, it is probability of A plus probability of B minus probability of A and B. 0.1 plus 0.3 is 0.4 minus 0.6 is 0.34. That's your final answer. Let's go ahead and take a look at the next one. If A and B are events, probability of A is 0.4, probability of A or B is 0.89, probability of A and B is 0.01. What is missing is probability of B. They're asking us to find it. They're asking us to go backward. They're asking us to find probability of B. So if I write down the formula, it's probability of A or B is probability of A plus probability of B minus probability of A and B. So I'm going to go ahead and plug in those values underneath here. Probability of A is 0.4. Probability of B, I don't know. That's what I'm trying to find. Minus probability of A or B is 0.01. And probability of A or B is 0.89. So if I combine these two, right, what do I end up with? 0.89 is equal to 0.4 minus 0.1 is 0.39 plus probability of, do I have enough space here? Looks like I don't. I'm gonna squeeze this in and I am just gonna minimize this one and move it right here. So let me erase this and erase it and rewrite it. So I have 0.89 is equal to probability of B plus 0.39. Because when I combine these two, right, I end up with 0.39. And now what do I end up? Minus subtracting 0.39 from both sides, 0.39. I have 0.5 is my probability of B. Simply doing the basic math, right? Now let's go ahead and look at the word problem. If the probability of a student spending time on reading is 0.7 and the probability of spending time watching TV is 0.1, I highly doubt that. And the probability of spending time reading and watching TV is 0.01. What is the probability of the student spending time reading or, the keyword is or, watching TV? So let's go ahead and I'm going to change the color here. So probability of spending time reading or watching TV, I'm going to put T for TV, is simply probability of reading plus probability of watching TV minus probability of reading and watching TV. What do I end up with? Probability of reading is 0.7, right? Let me pull this up here. Probability of reading is 0.7. Probability of watching TV is 0.1 minus probability of reading and watching is 0.01. So if I add all of them, I end up with 0.79. Hopefully that's right. Yeah, 0.7 plus 0.1 is 0.8 minus 0.1 is 0.79. There you go. That's your final answer. Let's try the next one. If the probability of selling brownies is zero point 0.2, probability of selling root beer floats, what are they? Root beer floats is 0.4. Probability of selling brownie and root beer floats is 0.1. What's the probability of selling brownies? The keyword is or root beer floats. Let's go and plug it in. Probability of selling a brownie or root beer. I'm going to put R for root beer. Is probability of selling brownies plus probability of selling root beer minus probability of brownie and root beer. Now I have 0.2 plus 0.4 minus 0.01. 0.2, 0.4, 0.6. 0.6 minus 0.01 is 0.59. And that is your final answer. Okay, so simply the word or means you're adding probability of the brownie plus probability of the root beer, but you subtract the ones that you added again. That's why you have to subtract probability of A and B. All right, let's look at the next one. Using the complement rule. Let's just say the probability of raining today is 70%. What's the probability of not raining? 30%, right? Where'd you get that from? You simply subtract it from 100%. So complement is simply you subtract that particular probability from either 1 if given to you in decimal or 100 when given to you in percentages. So it's a complement is when you add both of them together, you end up with a 1. So here you go. The rule of complement is that probability of A, oops, wrong pen. Probability of A is simply 1 minus probability of A complement. The way you represent complement is with that small hyphen right here, right? So let's go ahead and take a look at the problem. A random number generator is selecting numbers in the range 1 through 50. What is the probability that the random number generator will select that is not a multiple of 7? I'm not going to use complement. Let's keep it simple here. You have numbers 1 through 50. 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 50. So you have 50 numbers here, right? So again, it's the probability. So probability of not a multiple of 7. Remember, when you find probability, you always start with your sample space. No wonder my iPad is moving up and down. I forgot to put my glove here. Sample space, you have 50 numbers. 1 through 50, you have 50 numbers. And you do not want multiples of 7. So let's start to see how many multiples of 7 we have in numbers 1 to 50. 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, 7 times 6, and 7 times 7. Because anything after 49 is going to be above 50, so I don't need that. Except for these numbers, I can count every number. So how many numbers do I have? I have 1, 2, 3, 4, 5, 6, 7. So in 1 through 50, I have 7 numbers that are multiples of 7. But I do not want multiples of 7. So if the 7 of them are multiples, the rest of them are not multiples. So from 50, if I take away these 7 multiples, I'll end up with 43. So it's 43 over 50. Okay, so not multiples of 7. If I take off the 7 numbers, the rest of them are not multiples of 7. Let's go ahead and take a look. Bags of food are labeled 1 through 50. Okay, the dog, what is the probability that the dog will choose a numbered bag that is not a multiple of 11? So I'm not gonna write all the numbers 1 to 50. I'm just gonna write down multiples of 11. So probability of not multiple of 11. Again, probability, you start with your sample space. How many numbers do you have? 50. And they do not want multiples of 7. So let's see multiples of 11. Let's see how many multiples of 11 do I have from 1 through 50. 11 times 1, 11 times 2, 11 times 3, 11 times 4. I can't take 11 times 5 because it goes above 50, so I don't need that. How many multiples do I have? 1, 2, 3, 4. So out of 50 numbers, 4 of them are multiples of 11. The rest of them are not. So 50 minus 4 is 46. So 46 of them are not multiples of 7. What do I keep saying 7? Multiples of 11. Again, simplify your answers, which is 23 over 25. And that will be your final answer. Okay, so you're simply taking off all the multiples of 11 from 1 through 50. So you're left with 46 numbers. 46 over 50, you simplify to 23 over 25. All right, let's go ahead and look at the next one. There are 26 cards in a hat, and each of them contain a letter alphabet. If one card is chosen at random, what is the probability that it's not between H and J inclusive? So if I write my alphabets A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and all the way up to Z, right? They do not want H, I, J, H through J inclusive. That means I have to take off my H, I have to take off my I have to take off my J. Fair enough? So they're asking me for the probability. I'm going to name this event E. You always start with your sample space. How many cards do you have in the heart? In the hat? 26. Remember, you're taking off H, I, and J. So if you take off those 3 cards from 26 cards, how many are you left with? 23. 23 over 26 is your probability of picking a card that is not H, I, or J. All right. If the probability that a randomly chosen college student wants to design a smartphone app is 0.22, so let me highlight that, 0.22, then what is the probability that a randomly chosen student does not want to design a smartphone app? Does not want to design is simply the complement. Remember how you find complement is 1 minus probability. So if I subtract 0.22, so it's simply saying that she wants to design an app 22%. What's the percentage that she does not want to design an app? So it's simply 1 minus 0.22, which is 0.79. So there's 22% chance you will design an app. There is 78. Where did I get 9 from? There's 78% chance you will not design an app. Fair enough? All right, now let's go ahead and take a look at the last problem. If the probability that a randomly chosen college student is up to date on vaccine is 0.42, then what is the probability that student is not up to date? Again, it's the complement. I'm going to name this event A. 1 minus 0.42, which is 0.58. So there's a 42% chance you're vaccinated. That means there's 58% chance you are not vaccinated. Because when I add both of them up, I need to get a 100%. I hope this helps. Again, if you have any questions or concerns, please email me or reach me through Teams. Take care.